will have a quiz on Thursday, and that quiz will cover 2.4 and whatever section of 3 that we get to. We may or may not get to 3C, 3.1C. It just depends on how this week goes. I want to keep it kind of like up in the air right now because I don't know what's going to happen with the hurricane and with this week in general.
Well, most likely off Wednesday, Thursday, Friday.
We'll see, yeah. So it just really depends. However, if we are here and everything's good, we'll be doing C, and if not, then we'll end at B because we'll be doing B tomorrow. So we'll definitely get through A and B. All right.
What day is the 29th?
It is Thursday.
We're not going to be here.
We'll see about that. All right. So normally we calculate slope we calculate the average rate of change by calculating the secant line, the slope of the secant line between 2 points. This is what our whole lesson was about on Fridays. Everybody remember that?
Yes.
Okay. Now, what we're going to do is we're going to write this in a way that's more theoretical so you can have a better understanding of what this all means. Okay? So, step 1 is to find the coordinates of each of these points. So these are they're not going to be numerical coordinates. So the coordinate of this point is x comma y, which is f of x, right? Mm-hmm. And the coordinate of this point is x plus h, comma f of x plus h. So I'm just taking their x, okay, that's their x coordinate, and then f of whatever x is the y value. Okay, if you were to plug f of x into the function, or whatever x is, you get the output. So that's your x and y coordinate. Now h, you're going to notice this come up in the world of derivatives a lot. So let me explain what h represents. H represents the horizontal distance between the x values. So do you see how it represents that horizontal distance? Okay. So now that we found the coordinates, we're now going to go ahead and set up how we would normally find slope, right? So to calculate the slope of the secant line, you would do the change in y over the change in x. So the change in y is f of x plus h minus f of x over x plus h minus x. So I just did the change in y over the change in x. y2 minus y1 over x2 minus x1. Now what do you notice happens to the x's in the denominator of this fraction? They cancel out. So m is equal to f of x plus h minus f of x over h. So this is actually a portion of the derivative formula. So now we're going to talk about one last thing we need to add to it. The slope in this case is the slope of the secant line in the picture, which is the average rate of change. But say we wanted to calculate the exact slope at f of x. We can take the limit of the slope as we approach 0, as h approaches 0, because as h approaches 0, we get closer and closer to this coordinate right here, right? We get closer and closer to the coordinate x comma f of x. So the idea is we are trying to convert this from calculating average rate of change to instantaneous rate of change. Average rate of change is the average rate of change over an interval. Instantaneous rate of change is rate of change at an exact point. So we can calculate the exact slope at this point by taking the limit as h approaches 0. We get closer and closer to that point, just like all the other limits we've taken in this class, right? We get closer and closer to that point as we approach it. And as h approaches 0, that means the distance between these 2 points closes, okay? So to write the actual formula, it's just the limit as h approaches 0 of whatever that formula is that we have on the other page, f of x plus h minus f of x over h. That's the formula to calculate instantaneous rate of change. We call this the derivative formula. And now we're going to compare. So would calculating average rate of change over an interval of -1 to 7 or -1 to 3 be closer to instantaneous rate of change? Explain. What do you guys think? What's your guess? Which one's closer to instantaneous? Which one's a more precise calculation to an average rate of change? 1, 3, the second one, good. Because this one's going to give us less variance, right? So that's because it's a smaller So instantaneous is at that exact point, but we can get close with average rate of change. Alright, so now we're on to your notes sheet, so go ahead and switch sheets. Now we're going to talk about derivative of a function. So this formula here, we just learned how we derived the formula. Instead of x, you're going to sometimes see them use a. It's the same thing, okay? Essentially, we're taking the derivative, which is finding the rate of change at an exact point. So up until this point in math, you've never actually calculated an instantaneous rate of change, other than a linear function which has a constant rate of change everywhere, so any rate of change is instantaneous. You've only ever been able to find an average rate of change. So now is where that's all going to change. So let's talk about that. So average rate of change is always known by a secant line. A secant line is where you connect the 2 points and you find the slope of that secant line to find the average rate of change between the 2 points. Instantaneous rate of change is known by tangent lines. So tangent lines are a bit different. They only touch the curve once, and they help us find the exact slope at a point. So the slope of a tangent line is going to be the exact slope of a function at a point, and functions have infinitely many tangent lines. So at any given point of a function, you could draw a tangent line, and you could find the slope at that point. So you have to know the difference between a secant and a tangent line. I'll definitely ask you this on a quiz or a test or something like that. So make sure you know the difference between the two. One touches twice, one touches only once. So if we're looking at something like this, to find the slope of the secant line, you calculate it like any other slope. As p sub 2 moves along the curve closer to p sub 1, the horizontal distance between the 2 points gets smaller. And when h approaches 0, we have the instantaneous slope at p equals, or p1. So that's how we calculate the instantaneous slope, by finding the slope, the average rate of change slope, and then taking the limit as h approaches 0. So that's how you go from average to instantaneous. You take the limit. Let me know when you're ready. Continuing on, we're going to use the derivative formula to calculate the derivative of this function. So step 1 is you're going to look at your function, and your first part of the limit is going to be where you take whatever your function is, and whatever x is, you're going to replace x with x plus h. So first thing we're going to do is we're going to rewrite this, but we're replacing x with x plus h. Okay? So you see how I just took this function, but I replaced x with x plus h. Okay? Second part of the formula is minus, I meant to use the pen there, minus the square root of x minus 2. And this is all over h. So now we're just going to solve like we always do. Yes?
Why wouldn't you plug in x plus h for the second part?
Because the second part of the formula says they only want just regular f of x.
Okay.
Does that make sense?
Yeah.
Because if you were to plug in that again, you're just subtracting the same thing from itself. So what you have to do is you're trying to take the limit, just like any other limit we've learned about in this class. You can't just start always plug in the number, right? It's going to give us 0 over 0, or it's going to give us 0 in the denominator. So we have to use other methods. Do you guys remember the conjugate method? We learned about it. You had a quiz on it. So the conjugate method is where we multiply the top and the bottom by the conjugate of whatever the top is, right? Do you remember this?
Yeah.
Conjugate being where you change the sign between the two. And if I'm going to multiply the top by that, I also need to multiply the bottom by that as well. So I get here. And now I want to multiply the top out. Does anyone remember that when you multiply conjugates, do you need to do all the 4 steps of FOIL? No, you only have to do first and
Last?
last because the middle terms are always going to cancel.
Mhm.
So I have to multiply the first times the first. And what's going to happen when I multiply our square root by its exact self?
It's gonna cancel the square root.
Good. It's going to cancel the square root. Leaves me with this. And then I'm going to multiply the last, which also cancels the square root, right? And this is all over all that stuff from the denominator. Now, you don't want to multiply the denominator out because it's not going to help us here. So we get here. And then as for the numerator, I can rewrite this as x plus h minus 2 minus x plus 2 all over h times all this stuff. It's just a lot. It's a bit tedious sometimes. So just make sure that you double check your work so you don't miss anything. Now, stuff is always going to cancel out of the numerator. Basically, everything x or constant related will cancel out. So what's going to cancel out of this numerator here?
Your X's and your 2's?
And then, now that I have just h and I have an h down here, what can happen with the h's? They also cancel. And that leaves me with 1 over all this stuff. So you can write it out again. But remember, our goal is to take the limit as h approaches 0. Now are we ready to plug in for h? Can we plug in h now? What do you guys think?
Yeah.
Yeah, so what's that going to give us when we plug in h? What's going to happen right here?
Turn to 0. Or
So,
x minus 2.
yeah, it just becomes x minus 2 plus x minus 2 square root, which I can rewrite as 1 over 2 square root of x minus 2. Now, to write your answer, you're going to write f of x equals, and you're going to put this little prime symbol here that indicates that you've taken the derivative of it. So you're going to notice that unlike a lot of the other limits we've learned about in this class, your final answer often will still have x in it, and that's perfectly fine. Often, that's just how it's going to be. There's exceptions where you're going to get a constant function, that's okay. But you most likely will have x left in your final answer, because this represents a function, okay? Does anybody have any questions? Yeah?
I missed the part where you took away the h. What did you do there?
Oh, you understood how the h went away, right?
No, that's what I'm asking.
Oh, it's because ultimately our goal was to take the limit as we approach 0. So our goal when we take a limit is we want to be able to do direct substitution. So we had to do a method that would get us to a point where we could do direct substitution.
So just plug in 0.
Yeah, so once you get simplified down enough, you can plug in a 0, which just is going to make that h go away.
Yeah.
And then 2 of the same thing added together is just 2. Yep. Any other questions before we move on? Okay. So the next question is we're going to find the derivative of x squared plus 4. So we're going to do the same method as before. The limit as h approaches 0. So that's going to be, we're going to take the function, and we're going to replace x with x plus h. That's step 1. Minus, then you're just going to minus whatever the actual function is. And that's all over h. So remember, you just take the function, and you replace x with h, x plus h for the first part. So does anybody have any questions about just this setup part? Alright, so we're going to have to multiply x plus h out. I'm just going to do it on the side. And you're going to see we have to multiply x plus h times x plus h a lot, so it may help even to memorize what this is multiplied out. So first times first, last times last, inners. Oh, I meant outer and then last times last. So these are like terms with a coefficient of 1. So this becomes x squared plus 2hx plus h squared. So I can now replace x plus h squared with this in my formula. So I get the limit as h approaches 0, x squared plus 2hx plus h squared plus that 4, and then I distribute this negative, minus x squared minus 4 over h.
X squared is equal to
So you're gonna notice that every single time, everything that doesn't have an h in it will cancel out. That's just how it works. And then, now that I get to this point, can I factor out an h in the numerator? Yeah, and it would leave me with this, right? Now why would I do that?
Cause it cancels out your h's.
Good, it cancels out these h's, and it leaves me with the limit
Yeah.
of 2x plus h. So now I can finish my limit by plugging in 0, which just gives me f prime of x is equal to 2x plus 0, which is just what?
2x.
2x. So any questions on this one before you try your homework? Alright, I'll hand out your homework then. It's just tedious, but yes.
Just scroll up a little bit.
Sure.
I don't know what you meant with all that.
Oh, the one on the last one?
Yeah, did you already erase it?
Oh, no, I just was